Okay, so we're continuing on from question 2 of the 2009 HSC paper. Okay, so the question says the polynomial of x, which is in this case x cubed minus ax plus b, has to be divided by, well, first of all, x minus 1, and it gives me a remainder of 2. And then the second one is divided by x plus 2, and then the remainder is 5. Okay, so they give me this information. What I need to figure out is what is A and what is B. Okay, so in order to do this, it's a really simple thing to do. What you need to do is you need to go P of 1. The reason I'm saying P of 1 is because of this one. So just switch the signs and put it in there, and I will end up getting 1 cubed is just 1 minus A plus B is equal to my remainder 2. Right? So easy. And then the polynomial, the second clue that I have is P of negative 2 is going to end up being, so negative 2 to the power of 3 is going to be negative 8, and then minus 2 will give me plus 2a plus b is equal to 5 in this case. Right, so I just need to play around with these two equations, and I can solve this simultaneously. Okay, so the first one I will end up getting, what will I get? Minus a plus b is equal to 1, and with the second one I will end up getting 2a plus b is equal to 13. Right, so I'll call this equation 1, equation 2. And to solve this, so solving this, you should be able to do it considering you're doing 3 in it, but anyway, I'll just go, let's see, I'll go 2 minus 1. Okay, equation 2 minus 1, I will end up getting 3a, the b's cancel out, and 3a is equal to 12, therefore a is equal to 4. Plugging this back into, say, this equation, right, a is equal to 4, I have minus 4 plus b is equal to 1, b is equal to 5. Okay, so there you go, a and b. Right, so that's part A done. Okay, part B. So part B is slightly hard question, but it's, if you remember this formula that I'm going to show you next, it'll make it a whole lot easier. They want you to express 3 sine x plus 4 cos x as a sine in brackets x plus alpha. Okay, in order to do this, what I need to do first of all is to expand this out. Okay, so I'll leave the a. Now sine expanded goes sine cos sine, right? So the first term will be sine x cos alpha plus, again, a cos x sine alpha. So you need to sine alpha, sorry, my mistake. So that should be alpha, this should be alpha, sine alpha. Okay, I'm running out of room, but anyway, you get the idea. So I have a sine x cos alpha, and a cos x sine alpha. Now what I need to do is I need to look at the original equation that I got, right? So if you look at the first term, I have 3 sine x. I have a sine x over here. There's a cos x over here, there's a cos x over there, right? So basically what this means is that my a cos alpha is equal to 3, right? So basically the remaining term, my a cos alpha has to be equal to 3, and a sine alpha from the second term has to be equal to 4. Okay, so in that case, now I just need to solve this simultaneously. 2 unknowns, 2 equations, you should be able to solve it. But to solve this equation, there's one quick method of doing it, and that's to go, the first one, you need to go 1 squared plus 2 squared, because that way I will end up getting a squared cos squared alpha plus a squared sine squared alpha, which is, guess what, simply equal to a squared, right? But anyway, it's going to be equal to 3 squared plus 4 squared. Okay, so this side will simplify down to a squared. Why? It's because if you go cos squared plus sine squared alpha, that's equal to 1, right? I hope you understand that bit, because that's the most crucial part of this, right? So a squared is equal to, in this case 25, a is equal to 5. We don't actually care about the negative solution, it's only the positive solution that we're after. All right, and in the same way, to get alpha, I need to go 2 divided by 1. Okay, so that way I get rid of a, right? And now I end up with tan alpha is equal to 4 on 3. Okay, and you can get alpha using a calculator. Alright, alpha is simply equal to tan inverse of 4 on 3. And I'll let you plug that in the calculator yourself. Okay, part C. Let's see what part C is. Okay, sorry, there's a part 2 of that. It says, hence or otherwise, solve 3 sine x plus 4 cos x is equal to 5. Okay, now this is actually a fairly easy way of doing it, and it says x is between 0 and 2 pi. So sorry, let me just write that down. X is between 0 and 2 pi. Right, so basically what we're going to do instead is go a, so from the first one, a sine x plus alpha, so I don't know what the number is, so I'm just going to write alpha, has to be equal to 5, right? So there you go. So looking at this, sine x plus alpha has to be equal to 1, right? So rather than thinking of this one, we're actually dealing with this one, this equivalent trig instead, right? So sine x plus alpha equals 1. Therefore, x plus alpha. Now, before I get on to doing x plus alpha, I need to tell you one thing. So if you look at this thing over here, x is between 0 and 2 pi. Instead, what I want to do is I'm going to say x plus alpha is going to be between alpha, 0 plus alpha is alpha, and 2 pi plus alpha. Okay, so x plus alpha has to be within this range. Okay, so x plus alpha can be equal to well, remember in a circle there's 2 solutions, right? But you got to remember that this time it's between alpha and 2 pi plus alpha. All right, I'm gonna pretend that alpha is less than 90 degrees, right? So alpha in this case is going, actually in the question it says alpha is less than 90 degrees. So in this case, x plus alpha is going to be equal to pi on 2, right? And once the next time that it's equal to 1, so if you remember your sine graph, it looks like this, right? That's pi on 2, that's going to be 2 pi on 3. Okay, so to get x, you simply minus alpha from these 2 solutions. All right, so and that should end up within this range. All right, you just need to check that x plus alpha is within this range, and therefore x is going to be within and going to end up within this range over here. Okay, moving right along, part C. Okay, so part C. Okay, so the part C has this parabola, and the parameters, it's got this parameters called p2t, t squared. Now what you've got to be careful is the second point, Q, is 4t squared, sorry, 4t and 4t squared. Right, so a single parameter t controls both of them, both the points, okay? So there's a relationship between the 2 points. The tangents meet at a point R. Okay, so I'll just reproduce this. It's going to be a really bad drawing, but anyway, bear with me. So that's my ugly parabola, and then there's a tangent over there. There's a tangent over there, and I'm going to call this point over here R. That point over there Q, and this point over here P. All right, so okay, so the first question is saying show that the equation the tangent at P is y equals tx minus t squared. So this is what I need to show. All right, and the equation, before I jump into the question, the equation of the parabola is x squared equals 4y. All right, okay. Any tangent question, what do? You just need to find the gradient, right? So this I can rearrange and say y is equal to x squared on 4. So therefore y dash is equal to 2x on 4. Right, simplifying this, x on 2. Now I need to look back at this to say, hey, my parameter is 2t, right? So at x equals 2t, y dash is equal to 2t on 2, which gives me t. All right, great. All right, and now I just use my usual y minus y1 is equal to my point gradient formula, mx minus x1, right? So this is going to end up being y minus t squared is equal to t times, because that's my gradient, right? Over here, x minus 2t. Right, so expanding the right hand side, sorry, I will end up with xt minus 2t squared, and this will simplify down to y is equal to tx minus t squared. Okay, so that's what the question is asking you to do. So that was fairly straightforward. Only thing you really need to remember is to find the gradient using differentiation and then plug it into the point gradient formula. Okay, write down the equation of the tangent q and find the coordinates of the point r in terms of t. Okay, so we can do exactly the same thing for, so this is at p, right? And at q, the tangent at q is going to end up being, so I need to use this thing, right? Q is 4t and 4t squared. So let me rewrite this over here, 4t and 4t squared, right? So again, plugging the gradient into this formula over here, x on 2, right? My gradient this time is going to be 2t, right? So anyway, I'm going to write it up straight away. I'll let you work out the details, but so the gradient this time is going to be 2t and x minus 4t. Okay, all right, so expanding and simplifying this, I will end up getting y is equal to 2tx, and these two multiply will give me minus 8t squared, and that should end up being minus 4t squared. Okay, so I have my gradient, my tangent formula at q. Right, so minus 8t squared. Okay, all right, so to find r, it's simply a matter of doing simultaneous equations with these two, right? So equation 1 over here and equation 2 over here. Okay, so what am I going to do? So I can simply equate them straight away, right? Because y is equal to y, right? Or actually I'll just go 2 minus 1, right? Just for ease sake. So I'll end up having 0 is equal to tx, right? So because that minus that will give me tx, and this one minus that will end up giving me minus 3t squared. Right, so solving for this, for x, I will end up getting x is equal to 3t, right? Okay, so x is equal to 3t, and plugging this into any of these, either of these equations, right? Doesn't matter which one it is, I'm going to plug into the first one. I will end up getting y is equal to tx, so t times 3t minus t squared, so that will end up giving me 2t squared. All right, so there are coordinates, right? Okay, so the coordinates, I'll write them down separately. R is 3t, 2t squared. Now they want you to find the Cartesian equation of this, so the locus of this, right? So basically if I say x is equal to 3t and y is equal to 2t squared, so by the way, this is part 3 of that question. Okay, sorry I didn't explicitly state that, but anyway, x is equal to 3t, y is t squared. I can say x on 3 is equal to t, right? And sub this right back in here. Okay, so in the end, I will end up with y is equal to 2 times, instead of writing t, I'm going to write x on 3 all squared. Right, so I will end up with 2x squared on 9. Okay, so that's it for question 2. If you have any questions or comments, let me know. I'm pretty sure I would have done most of this correctly, but hey, I'm only human. I might have made mistakes, so let me know. And thanks for watching.